In this video, I want to quickly talk about just some simple probability and simulations. Okay? So, if a dice is rolled, list the possibilities. So, I'm going to do my best to make a bracket here. It probably won't look great. Let me try that again. So, the possibilities are, of course, any side like that. Okay? Then we call this a sample space, where we've listed all the possible outcomes. Okay? And again, excuse my poor brackets. It's not the pen, it's just me. Find the probability of an even number. So, of course, the probability that we roll an even, there are three even numbers out of 6 possible outcomes. So you'd say, well, it's 3 out of 6, or 1/2, or 0.5, however you want to write that. Okay? An odd or a 2. So now you say, well, there are, of course, 3 odd numbers, but adding a 2 in there, saying that we either could get an odd or a 2, 4 out of the 6, or 2/3. An even or a 2. Well, now we have 3 even numbers. 2 is one of them. So to say a 2 again would be counting it twice. So we're back to just 1/2. An odd or an even. Well, every number in there is either an odd or an even. So all 6 outcomes out of 6. An odd and a 2. Well, if you roll the dice once, it is not possible to get an odd and a 2. So the probability is 0. Finally, not a 2 or a 3. So if you take out the 2 and 3, there are 4 outcomes left. So 2 out of 3. All right, let's look at some simulations. So tossing a coin. I want to simulate tossing a coin 20 times and counting the number of heads. Okay, so if I was going to do that on my calculator, I'd probably just say, all right, rand int 1, 2, 20. And then I would just assign. I'd say if I see a 1, it's heads. If I see a 2, it's tails. On a random digit table, you'd just pick a line and start reading, and you'd say, well, if the number is odd, let's call that a heads. I should probably put actually odd. And if the number is even or 0, we'll call that a tails. Because, of course, 0 isn't even. So we'd say even. So odd, we'd count as a heads. Even or odd, or even or 0, we'd count as a tail. All right, rolling a die 10 times and counting the number of 2s. Okay, so using the calculator, this would be easy enough. We do rand int 1, 6, 10. And of course, we would just count the 2s. Easy enough. On the random digit table, we look for the numbers 1 through 6. Okay? And we find 10 of those in a line. And any other numbers, we'd ignore. We'd just skip them. Okay. All right, 32% of men will go bald. Simulate 30 men. All right, so this is kind of similar to the Joe Mauer example we did in the last lesson. To simulate on our calculator, easiest way, we do rand int. Maybe do 1 to 100. And I said simulate 30 men, so 30. And we'd say, well, 1 to 32 is bald. I'm just going to put a B. 33 to 100. I'm going to put an H for hair. Okay, maybe I should actually. They don't go bald. Okay? Now, on the random digit table, I would do this just a little bit differently, because if you start saying, well, I'm going to do 001 to 100, and I'm going to look at those numbers, you're now doing 3-digit numbers, and a lot of those 3-digit numbers you're not going to use. You're not going to use 900 of them. If you get 200, you're going to skip it. So instead, I would look at 2-digit numbers, 00 to 99. Okay, so looking along a line at 2-digit numbers, and I'd say, well, 0 to 31 is bald, and 32 to 99 keeps their hair. Okay, and again, just think, if you go 0 to 31, that's 32 numbers. So we've kept this scale correct. Okay? 5% of all Northwest Airlines flights are late. Simulate 25 flights. So again, on the calculator, doing a percent, we just do rand int. 125 flights. And you'd say, well, 1 through 5 is late. And 6 to 100 is on time. Okay, and with the calculator, again, I would probably stick with, with the random digit table, I would probably again stick with 2-digit numbers. So I would do 00 to 99. Look at that, and maybe 00 to 04 would be late. And 05 to 99 would be on time. Okay, so this, again, just some ways to run simulations to check our probability and find out likely outcomes.